Good afternoon, Robert Scribbler. It is July 9th, 2018. Thank you for joining me for another climate change and clean energy video blog. Now, for this segment, I'm going to talk a bit about electrical vehicle sales in the United States and why rising electrical vehicle sales in the United States and around the world is so important for confronting the crisis that is human-caused climate change. But before I do, I'd like to talk to you a bit about causes of climate change. The reason why we're going to talk about causes of climate change in relationship to renewable energy is there's a lot of effort right now to cloud the link between fossil fuel burning and global warming. This has historically been a long-term effort by fossil fuel interests to cloud this link in the public mind, and I just want to reassert the facts. Now, this NASA graphic shows the level of atmospheric carbon dioxide in the Earth's atmosphere at present, actually, as of 2013, and in comparison with the past 500,000 years. Now, as you can see, at no time, and I'm sorry, I'm going to say this is the past 400,000 years as the start of the graph, at no time in the last 400,000 years have carbon dioxide levels ever been this high. And according to our paleoclimate proxy data, it's likely that this year carbon dioxide levels in the range of 411 to 412 parts per million at peak in May is roughly comparable to atmospheric carbon dioxide during a time called the Middle Miocene at about 15 million years ago. So if you're looking at atmospheric CO2, you've got to go back about 15 million years or so to find a comparable period of time. Now, why is this so important? It's important because CO2 itself has a molecular structure that traps heat and re-radiates it. So, or traps radiant energy and re-radiates it as heat. So as sunlight comes in, it excites carbon dioxide molecules, and those molecules re-radiate heat into the atmosphere. Now, it's well known that carbon dioxide has this property. If you fill up a test tube with carbon dioxide and shine an infrared light on it, it will warm up. And we use this technology to do such things as develop heat-seeking missiles. So if you don't believe that carbon dioxide traps heat and re-radiates it, then you don't believe in heat-seeking missiles. So according to NASA, this relentless rise in carbon dioxide is a result of human-caused fossil fuel burning. And presently, we're able to tell where the carbon dioxide comes from by measuring the isotopic ratios in the carbon dioxide. So, for example, if you take a sample of carbon dioxide in the atmosphere and look at the isotopes, it matches the isotopes that come from fossil fuel burning. And to a much lesser degree, it matches the isotopes coming from volcanoes. And in fact, if we compare these isotopes, we find that carbon dioxide is being emitted by fossil fuel burning at a rate of 100 times that presently being emitted by volcanoes. So the primary cause is fossil fuel burning. And what NASA finds is that if fossil fuel burning continues at a business as usual rate, such that all the fossil fuels in known existence that we have been able to discover are burned, then ultimately atmospheric CO2 will continue to rise to levels of around 1,500 parts per million. And if you look back at past climates when atmospheric CO2 levels were so high, that corresponds to approximately 12 to 15 or 16 degrees Celsius worth of warming on a global basis. And that level of warming, it is absolutely catastrophic. 2 degrees Celsius warming is bad. 12 to 16 is is almost incomprehensible. So before I go on, I'm going to talk a little bit about electrical vehicles and how replacing fossil fuel burning that is causing this problem is so important. But before I do, I'd like to read this quote from NASA. The bottom line is that atmospheric carbon dioxide acts as a thermostat in regulating the temperature of the Earth. The rapid increase in atmospheric carbon dioxide due to human industrial activity in the form of fossil fuel burning is therefore setting the course for continued global warming. So, I've spoken a lot about electrical vehicles, and I just want to say a couple more things. So electrical vehicles themselves, the motors are 4 times more efficient than a gasoline engine. So just by itself, just out the gate, just due to efficiency, electrical vehicles are going to result in less carbon emissions because they use less energy. Now, there are some other factors. An electrical vehicle is charged by a battery, and that battery can be plugged into any energy source. If the battery is plugged into wind and solar, that vehicle uses 0 carbon emissions in use. Electric generation through wind and solar produces 0 carbon emissions. Now, the only carbon emission that is produced in such a process, such a renewable energy-based system, is carbon emissions that come from building the cars themselves. Now, if you look at carbon emissions coming from transportation, the amount of carbon emission that comes from actually constructing vehicles versus running vehicles on oil or diesel or gasoline is considerably less. It's about 20% to 1/3 at most, depending if you're using a very high carbon-based manufacturing process. And this amount of sunk carbon emission in producing a vehicle can be greatly reduced by, for example, using renewable energy to power manufacturing, using electrical vehicles or other renewable energy-based systems to transport the materials to the factory, and by using decarbonized forms of steel and aluminum. And there are a number of systems now coming into play that are enabling the 0 carbon or low carbon production of steel and aluminum. So in the end, what an electrical vehicle enables you to do is to completely remove or nearly completely remove carbon emissions completely from the process of building and driving an electrical vehicle. There is no such opportunity for fossil fuel-based vehicles. Presently, electrical vehicles emit between 30 and 50% the life cycle carbon emissions, including wells-to-wheel emissions. And this level of emissions is falling as the chain of energy production and materials production becomes less carbon intensive. So if this report, as this Inside EVs reports notes, that United States electrical vehicle sales are on track to hit 25,000, 26,000 or more in June of 2018, then that is very good news. And as we can see from this chart produced by Inside EVs, Tesla again is leading the pack in the United States, producing over 11,000 electrical vehicles by itself, and is likely to continue to surge ahead. Now, there are a number of other clean energy vehicle leaders in the US, and these include the Toyota Prius Prime, the Chevy Volt, and the Nissan Leaf. But unfortunately, these companies are not aiming to as rapidly increase electrical vehicle production and meet what is a widespread demand for clean energy vehicles. However, the good news is clean energy vehicle production has surged by 50% in June and is likely to surge by 100% this year overall.